So students, moving on to the next question here, that is question number 3rd, and it says that consider two postulates given below. Now I'm reading one by one the postulates given to us. The first one is, given any two distinct points A and B, there exists a third point C which is in between A and B. So this postulate is actually saying that there are two distinct points like A and B, right, and there exists a third point C. Suppose if I join this line, let me just correct it like this, and there is a point C which is in between this A and B like this, right? So moving on to the second one, it says there exists at least 3 points that are not on the same line. So the second postulate is actually saying that the 3 points are non-collinear. That means they are not on the same line, right? So if I just simply join this, so B is not lying on the line, right? So this is the condition here given to us. So the question is asking us that, do these postulates contain any undefined term? Now let me just take a look over here again, and then you will find out that the word point, as I've told you, point is a dimensionless structure. Point has got no dimensions. So this word, or you can say the term point here, is undefined. Let me just check out another undefined term here. So I will be like line. So line is also a undefined term, because if I just take a look over the definition that I have told you in the previous version, that will be like that a line is a breadthless length. So it has got no breadth, right? So it is also a undefined term. So if I just see here, that then I will find out that there are two undefined terms here. So this first line will say, let me just make some space here so you can understand it better. So let me just write the solution here. So that will be these postulates contain undefined terms as points and line, right? Let me just move to the next question asked by this. So that is, are these postulates consistent? So consistent, let me first tell you that how we will check whether these two postulates are consistent or not. So for that, let me just tell you, these two conditions are completely different situations here. So definitely these are going to be a consistent situations. As you can see here, previously I have drawn 2 points here. I have joined them and taken a point C that is lying on that line AB. So that is a consistent situation that can happen. Whether if I just taken the second condition here, or you can say second postulate, that is also a possible condition in which I have drawn a line AB and I have taken another point that is not lying on it. So these are completely two different situations and that are possible. So these two postulates are consistent because both the situations are different. So let me just write that these postulates are consistent as these are two different situations. So I've got the answer to the second part here. Now the last and the third one is, do they follow from Euclid's postulates? So do you think that the postulates that I've told to you recognize these? No, these are not referred from Euclid postulates. They do not follow Euclid postulates because there is no such postulate given by Euclid. But if you remember, there is an axiom, that is 5.1 axiom, that refers to these, and that was, let me just write that postulate here for you. So let me make some space here. So let me write that axiom for you. That axiom 5.1 says that given two distinct points, there is only one line, or you can also say unique line, passing through it. So this was the axiom 5.1 given by Euclid, that says there's only one line that can pass out through two distinct points, right? So there's only unique line that can pass out through two distinct points. So that some kind of resemble to the two postulates given here. We have taken the two situations where I was taking two different points and just joining a line here. So this actually resembles to the axiom 5.1. The two postulates given here resembles to axiom 5.1. That's all. So students, let's just jump over to the next question here. Now question number 4 says, if a point C lies between 2 points A and B such that AC is equal to BC. So first let me just draw a line here like A and B. So it is given to us that there is a line joined by 2 points, namely A and B. Now there's a point C which lies between these 2 points. So let me just draw a point C such that this condition satisfies. This says AC is equal to BC. So let me just write out that given to us that AC is equal to BC. Now you can see this length is equal to this. So AC is clearly equal to BC. So we can conclude that C is in the middle of AB, right? That means this is actually the midpoint. Are you getting my point? So this is the midpoint of AB. That means this length is equal to this. It is given to us, right? So as we know that C is the midpoint of AB, so C is midpoint of AB, right? Now I can clearly write this length AB as AC plus CB, right? Let me just denote it as first equation. Now if you just take a look over here, that let me just denote this one as first and this one as second. Now if I just take a look over the first equation, that AC is equal to BC, right? So I can also write at the place of AC as BC or at the place of BC as AC. So do whatever you want. I'm just simply replacing this BC as AC because they are equal. So I'm just placing AC at the place of BC, so because they are equal values. So I can just replace this by this, right? So that will be equal to AB. Now you can see here AC plus AC will get me 2AC, right? Now if I just simply see here that if I just transfer this value 2, which is in the multiplication of AC, into the left hand side in the division, so that will get me like this, that AB over 2 is equal to AC, right? So you can see here there's nothing in the numerator with AB, so there will be 1. So you can just simply separate it as 1 by 2 AB equal to AC. So this was all that we have to prove here. If you just take a look over here, so we have to prove this by just simply taking a line which is having a midpoint C, so that AC equal to CB. So that's all for that we have to simply prove this, and it is hence proved. That's all. So students, without wasting much of your time, let's move further to the next question here, which says in question 4th, that means the previous one, we have discussed point C is called a midpoint of a line segment AB. So let me just recreate the previous scenario from the previous question. There was like something that we have drawn a line AB, we have taken a point C on it. Let me just, if possible, now but before that let me just read this question here. So this was the previous scenario. Now prove that every line segment has one and only one midpoint. So this question is saying that we have to prove that there is only one midpoint of every line, right? every line segment. So we have to prove that there's only C which will be the midpoint of AB. So there's no other midpoint also. So to prove that, let me just take out if possible, let me just take another value, or you can say a point D, and assume that if possible this is also a midpoint of AB. So let me just write it. If possible, let us assume that D is midpoint of AB. Now according to this, if D is midpoint, then definitely this line segment is going to be equal to this, because this is the midpoint. So AD will going to be equal to DB, or you can say BD. They are same. So if I just write AD equal to BD, right? So let me just give it first equation. But you all know that from the previous scenario I have taken C as midpoint. So let me just write that. But C is midpoint of AB, right? So according to this statement, then definitely this AC is going to be equal to BC. So let me just write that, because this is the midpoint, so definitely this length will be equal to this. So AC equal to BC. Let me just give it a second equation. Now there's a contradiction. So you can see this is also the midpoint, then this equation exists. But from the previous scenario, C was the midpoint, then the second equation exists. Now if I just simply subtract this equation from this, let me just subtract the first equation from the second one. So let me just write clearer that subtract, let me just be clear, subtract equation first from second. Subtracting equation first from second means first we have to take AC. So we are going to subtract from both the sides, as well as left hand side as well as right hand side. So let me just first take the left hand side, that is AC minus this AD, right? So doing the same on the right hand side, let me first take BC minus BD. So moving on to the structure here, this line segment, if you can see here AC minus AD. So let me just keep a value over here. So AC minus, you can see AD. So AC is greater than AD. So I am subtracting a larger value, first putting larger value, then subtracting the smaller value. You can see if I subtract AC minus AD, so if I subtract AD from AC, that will be DC. I'm just simply subtracting AD from AC, so the remaining will be DC, right? Doing the same over here, BC minus BD. Now you can see BC minus BD. Now BC is smaller than BD, so I'm just simply subtracting larger value from smaller value, so there will be a negative sign. Whenever we subtract 2 minus 4, there will be minus 2, because we are subtracting a smaller value from larger value from smaller value, right? So BC minus BD, remaining will be DC, but there will be of negative. You can see here BC minus BD, that will be removed, only DC will remain, but there will be of negative. So if I just transfer this minus DC over to the left hand side, that will become plus DC equal to 0. Now DC plus DC will get you 2DC equal to 0. So if I just simply transfer this coefficient 2, which is in multiplication, over to the right hand side, that will get me DC is equal to 0 upon 2. That is DC equal to 0. So you can see here, if DC length is 0 actually, that means both the points are coinciding each other. That means there is no difference between D and C. They are actually coinciding. This is D, this is C. So there is only one and only one midpoint for every line segment, right? So this is all we have to prove, that a line segment has got only one and only one midpoint. That's all. So students, moving on to question number 6 here, which says that in figure 5.10, this is the 5.10 figure which is given to us. Now in this, if AC is equal to BD, so it is given to us, let me just write here that AC is equal to BD, it is given to us. Let me just denote it as first equation. So you can see this length AC is equal to this length BD, right? Now we have to prove, let me just write that what we have to prove here is to prove AB equal to CD. This is what we have to prove. Now this is the solution here. Now starting the proof here. Now first step is, if you just take a look over this statement, this AC is equal to BD. Let me just take this AC as first one. So what is AC from this line here? So if I just take a look over AC, AC can be written as AB plus BC. So let me just write at AB plus BC. Then let me just give it as second equation. Now taking the right hand side, BD. So if you just take a look over BD, BD can be written as BC plus DC, or you can say CD. So let me just write that DC. So right, so that will be BD equal to BC plus DC. Give it a third equation. Now just simply substitute the equation second and third, that means the value of AC and BD, these into first equation. So I'm just simply substituting second and third into first equation. So just let me make some space here. So I'm just simply writing AB plus BC at the place of AC here. So I'm just simply substituting this over here. So that will be like AB plus BC, that will be equal to, now at the place of BD I will substitute third equation, that is BC plus DC. So I'm just writing BC plus DC. Now if you take a look over these 2 plus BC, both are of same sign but are on different sides. So if the values are same and also the signs are same, whether it is positive or negative, they will simply cancel out. So what is remaining here? That is AB equal to DC. This was what we were looking forward for to prove. You can also write DC as CD. So that will be like AB equal to CD. DC and CD are same. So this is what we have to prove here. That's all. So students, moving to the final and the last question, that is question number 7 here. It says, why is axiom 5 in the list of the Euclid's axioms considered a universal truth? Now, as I told you previously, all the axioms and postulates are assumption based on universal truths. Now, you all know universal truth is, if I just simply take an example here, that sun rises in the east. So definitely it is visible to us, it's a universal truth. Now, you can see here that why is axiom 5 is a universal truth? This is the question. Now it's also written in the note that the question is not about the fifth postulate. So it's not exactly about what fifth postulate is so that it is a universal truth. It's just asking why is it a universal truth. So let me just clear you that we are not discussing axiom 5 here. We are discussing why is axiom 5 a universal truth. So since axiom 5 is in the list of Euclid axioms, is true for anything in any part of the universe. Like if I just again take an example that sun rises in the east, so at any part of earth sun rises in the east. So nobody questions it because everybody observed this. It is visible to us that sun rises in the east, but nobody questions it because it's a universal truth. That's why this axiom 5 is true for anything in any part of the universe. That's why it is a universal truth, because it is possible is anything in any part of the universe. So let me just recall what was the axiom 5 here. That will just refresh your mind. So the axiom was the whole is greater than the part. So it is clearly visible to us that a whole thing is always going to be greater than the part of it. So it's a universal truth. That's all.